Postulate that proves the two triangles are congruent. You have the Santi special side, angle in the middle, side, SAS. The other one was SSS, and today we're learning two more. Okay, today we're learning two more. We're going to use ASA and AAS. And I think this picture is funny because that's the name of a bird, but I don't know. I just type out like ASA meme into Google, and then that picture popped up, and I was like, ha, that's pretty funny. And it probably means absolutely nothing, but it's funny for me. Funny for me. All right, so we did SSS and SAS 2 days ago. And, well, actually, we're going to go over those two again later in the class, so I don't want to kill too many birds. Speaking of birds, there's two more postulates involving sides that we're going to use. And stupid me, I accidentally covered the one of them. The next one that we're going to learn is ASA and then AAS, and I accidentally covered it. I wonder if that happened when I converted stuff into this Google Suite. The ASA postulate means you have, like, if I look at these two triangles and someone's like, are these two triangles exactly the same? What I would have had to do 4 days ago or 3 days ago, whenever it was last week, what I would have had to do last week when my cousin was teaching was I would have had to prove that all three angles are the same and all three sides are the same. But then I swoop in the other day and say that's not necessarily true. If you can prove 3 things on that triangle are the same as 3 things on that triangle, then you're good. But you have to be specific. Well, what ASA says is if I can show that an angle on this triangle is the same as an angle on that triangle, a second angle on this triangle is the same as a second angle on that triangle, and the side in between the angles are the same as the side in between the angles on that triangle are the same, then I can prove that they are the same using the ASA congruence postulate. These two triangles are the same because of an angle, a side in between, another angle. ASA. That introduces the phrase included side. The other day we introduced the phrase included angle, and included angle or included side means the angle or side in between the two things that you really, really, really care about. We have AAS. If two angles and a non-included side of, so that we're introduced to a new phrase, if two angles, so boom, boom, and a non-included side are the same, then the two angles are also congruent. So today we're going to discuss two angles and the side. In one case, the congruent side lives in between the angles. In another case, the congruent side lives outside the congruent angles. And the difference between those is nothing except for at the very end of the proof when I say, oh, this one's called the AAS theorem, and this one was called the ASA theorem. The ASA because the side was in between the angles, and the AAS theorem because the angle or the side was not in between the two angles. So our proofs are going to be like, check these two triangles out. Let me give you a little bit of information, prove that they're congruent. That's going to be today's lesson, and we're going to do 4 proofs. And honestly, you know me, I just copy and paste these proofs from your book, and I don't look at them ahead of time because I enjoy you seeing the thinking process. I want you to see what the thinking process of an ADHD genius is. And that way, those of you who are ADHD were like, oh, I see what he did there. Those of you who are geniuses are like, oh, I see what he did there. And those of you in-betweeners are just totally lost. But at the very least, I can affect 2 groups of people. Oh, it's fun. It's fun being the way I am. So these are the 4 triangle congruency postulates that we learned. Okay, 2 days ago, we did the SSS. Okay, if I'm given a proof and I can show that all 3 sides on this triangle match up with all 3 sides on that triangle, then my proof uses SSS. If I can prove that 2 sides on this triangle and 2 sides on that triangle are the same, and the angle in between are also the same, that's SAS. If I can show that 2 angles are the same and the side in between are also the same, ASA. And if I could prove that 2 angles are the same and then this weird side all the way out here are also the same, then I could use AAS. The non-postulates, the ones that don't exist, what I'm about to show you, there's no such thing. These aren't actual ones. There's no such thing as AAA. So if I'm doing a proof and I'm like, oh, those angles are the same as those angles, they're congruent because of AAA. There's no such thing as AAA unless your car breaks down. Looking at the chat for reaction, look at the chat for reaction, looking at the chat for reaction, looking at the chat for reaction, and nothing. Okay, AAA. That's all right. You guys are, oh, thank you, Camilla. Yes, thank you. Another one that doesn't exist is the curse word. So to keep my job, I'm going to write this out. That could also be written out as SSA. Those don't exist. So if you find an angle with a side and a side, now what these 2 are saying is a picture where maybe you have 2 triangles that look like this. You have an angle and an angle that match up. You have a side and a side that match up, and then a side and another side that match up. I can't use this to prove that 2 triangles are congruent. So those guys don't exist. Thank you. Thank you, Jill. Because what's going to happen is you guys are going to run to my YouTube. You're going to screenshot this and send this to Mr. Dorm and be like, look what Mr. Perich did. He cussed. And I can be like, I used dollar signs. Oh, Santi, really? Gosh darn it. But I like my job. I can feed my family. Listen. If if I wasn't recording this, man, would I just curse left and right. Oh, I just love unnecessarily using bad language to make me look cool, like you guys do. So if you went into law, you have a suit. I got you, buddy. I like that. I'm going to turn off. We're done with these slideshow now. I'm going to switch camera. I got you, bud. I got you, Paul. I liked it. And I'm switching over to my document camera. Make sure you pin my screen. And we're just going to do a bunch of proofs. 4 of them to be exact. So let's remember. And I'll just write it up here so we can remember. We have SSS, 3 sides are the same. SAS, 2 sides and an angle in between are the same. ASA, 2 angles and the side in between are the same. And, oh gosh, SAA. Was it AAS or SAA? How did we word it? How did we word it? Because it's the same thing. I just want to be consistent with the wording. Why is no one helping me? How did we word it? No, it wasn't SSA, AAS. AAS, sorry. Remember, the curse word or this curse word backwards are not one, and AAA are not one. Or if you're talking about, if you love Bible speak, if you love King James, a donkey. There's the smile from Carrie that I was hoping to see. Okay. Yay. All right. So we're given that picture right there. Okay. We're given that picture right there. Let me open up the chat so I can see. Remind me, you can unmute them yourselves, or you can not mute yourself or unmute yourself. What does bisect mean again? Put it in the chat or remind me what it means. When it divides into two. Okay, good. So CB, line CB bisects ABD. So it's going to take ABD. So if CB bisects ABD, then this angle and that angle are the same. Okay? Make sense? It should. By the way, CB also bisects ACD. So those guys are the same. Make sense? Yes, Chris. That's his name. Christopher Banuelos. My first statement, as always, CB bisects ABD and ACD. Make sure you're paying attention to the proof, because I'm going to bring back giving you proofs for asynchronous learning. Since we were able to say this, because of this, we were then able to say that ABC and DBC are congruent. ABC is congruent to DBC. Also, ACB is congruent to DCB. And that's the addition of what word? Definition of no, sir. Good guess. The word is in the given. Why am I allowed to say that these guys are congruent? And why am I allowed to say that these guys are congruent? The word is in the given. The word is in the part that says given. It starts with the letter. You guys are killing me today. Bisect. Thank you, Camilla. Oh, you guys. All right. Now, I have two angles, but I need three things to prove triangle congruence. What else can I show are equal to each other? Or is equal to each other? What else here is equal to each other? I'll give you a hint. We named it after a student. The middle line, there he is, saving the day. Good. So since CB is the same as CB, we can say that CB equals CB, the Santee special. So line CB is congruent to line CB. Yep, 3. That's the Santee special, but we're not allowed to say Santee special. We have to call it the reflexive property. Now, what I can do, I already used that color. Now what I can do is I have angle, included side, angle. So now, and that's one of these guys, now I could say that triangle ABC, triangle ABC is congruent to triangle DCB, and that's which of these four postulates that allows me to say that. Look at the picture up here. What do I have? Which of these four postulates allows me to say that these two triangles are exactly the same? Are they exactly the same because it's side, side, side? Is it side with an angle in between? Or as Lily said, ASA, because it's two angles with a side in between. We're done. Okay, I'll give you a second or two to copy stuff down. Megan and Russ, you should probably blow up my screen key on you too. Hi, Pot. Oh, no. Megan, I'm sorry, Paul, but Megan is first on our board because she's the first one who spelled it correctly. I did the secret word. All right, Megan, check. All right. Three checks and you get a timeout. Yep. Thank you, Camilla. All right, new one. Oh, that was fun. Look at all you paying attention. Except for who didn't respond. Most of you responded. That makes me happy. Oh, hi, potato noose. Ah, Paul. Ah. All right. Let's see. GH and FJ are parallel. I'm about to sneeze. Hold on. Excuse me. Let's write out our fours. We have SSS. We have Seth. We have ASA. And we have, I'm not going to say it, ACE. Those are our four. GH and FJ are parallel. Cool. Angle G and angle J are 90 degrees, so we already have an angle. We have an angle. So let's do our statements and reasons. Nothing more to label. GH is parallel to FJ. Oh, also, the measure of angle G is the same as the measure of angle J, which is 90, so they're right angles. I don't know why they just didn't say that. All right, so I have these guys right now. I have one thing. I need 3 things in order to prove that these triangles are congruent. And I have 1 thing, which probably rules out SSS. I'm not going to be able to use that. So maybe I can try doing the SAS, the ASA, or the AAS. Could someone give me any 2 things that are the same as each other? Any things that are the same as each other? FH equals FH, and that's, of course, the Santee special. So I have a side there. FH is congruent to FH, and that's the, what's the Santee special actually called again? Reflexive property, very good. It's nice to know that I'm not the only one who recognizes your poor spelling. Camille, your job for the rest of the year is just to make sure you just bash anyone who misspells something, including me. Relfexive. Oh, I love this class so much. All right. So I have a side and I have an angle. So all of these are still in play. This next one is not so obvious, so I'm going to do it for you because I don't think we've dealt with this situation in a while. When you have parallel lines, right? A line that touches 2 parallel lines also has congruent angles. And that comes from this thing that you were supposed to learn last year, but I'm not sure if you did. Say these guys are parallel. That is congruent to that. And this picture that I drew up here is supposed to mirror that. Like if I were to keep these lines going, and if that line were to go on forever, I would have these guys that are called alternate interior angles. So step 3 is I'm allowed to say that GHF, angle GHF, is congruent to angle HFJ. And that's, I taught it to you. I don't know if, whether you learned that last year, I know I taught it to you this year, but it's been a few months. So if you don't remember it, that's okay. That's why I'm going over it. This is the, definition of alternate interior angle. Can I now prove that these 2 triangles are exactly the same? And if I can, which one of these properties can I use? Do I need more information? No, we don't need more information. So these guys are congruent. HJF is congruent to FGH. The black triangles on these mean that they're parallel. Again, this is stuff that we haven't talked about in a couple months. So if we forgot that, that's okay. All right. Which one of these guys can I use? Remember, this means side with an angle in between, 2 angles with a side in between, and 2 angles where the side is not in between the 2 angles. It's not ASA, sweeties. You're on the right track, but the wrong one. AAS. And the reason why it's AAS is because these 2 angles and that side does not live in between the 2 angles. I understand maybe those triangles, those little black triangles, are throwing people off. But that just means they're parallel, not that they're the same. I mean, they are the same and because they're parallel or they're congruent triangles, but all right. 6 minutes. Ugh. Tell you what, let's do this. Instead of making a proof, look at the picture and tell me which oh, nose. Oh, okay. They're saying that this looks like the beak of a bird or it's a kite. Very good, friends. Thank you. This is what you're going to be tempted to do. So let me show you something that's wrong. You're going to be tempted to say, yes, the Santiago special. The Santiago special. So there's an angle, and there's a side, and there's a side, and you're going to want to use the curse word. Okay, but you have to remember, this does not mean anything. This is bad. Not only is it a bad word, but this is a bad proof. So you can't do that. That doesn't work. So pretend that the Santiago special isn't there anymore. What we would have to do is, this says that JL bisects KLM. So we could say this. And now that we could say this, we have a side with an angle, and the side is not in between. Which one of the four properties, oops, that's not one. Of course, I drew out the wrong one. Which one of the four properties could we use to show that these guys are congruent? Side, angle, and an angle. Which one of these would be our proof? You guys are killing me. Killing me. Nope, side, angle, angle. Not angle, side, angle. Side, angle, angle. Which one of these is side, angle, angle? Whoo! We're not going to have time to do this one either, but what we could do here, if we want, is since these guys are parallel and these guys are parallel, we can be like, alternate interior angles everywhere, everywhere, and the Santiago special, and that becomes ASA. All right. Fairly Odd Parents? Is that what we're talking about? Is that what's most important to you, Camilla? Fairly Odd Parents? Let's call it a day.